I'm Onno Bokhofer. I'm professor in geophysical fluid dynamics at the University of Leeds. We are showcasing the Wetropolis flood demonstrator at the Mathematics of Planet Earth exhibition at the Imperial College in London, and Wetropolis is part of the DARE project.
So, hello, I'm Oliver Phillips. I'm a PhD student at the University of Reading, and I'm part of the Mathematics of Planet Earth CDT, which is part of the event that's been organised here today, looking at lots of different sort of how maths is involved in the planet. And we've been showing around members of the public and just try and get people involved and interested in maths and how important it is to understand what's going on in the planet.
Wetropolis was part of a larger investigation on flood science policy, and Wetropolis triggered this flood science policy and a new tool we developed, and we sent it in as evidence to a parliamentary flood inquiry which was held in 2020. This is the Wetropolis setup. It has a river channel with water coming in upstream, and then the river channel winds down to its exit. Right at the end here we have the city, which can flood under extreme rainfall. We have the reservoir where it can rain. When rain falls in here, it flows immediately into the river. And we have here the moor, which consists of porous particles, and the rainfall can absorb, and then it flows here at the end into the river. And Wetropolis aims to visualize what the return period is for an extreme flooding event. Often people say after an extreme flooding event that this was an event that happens on average once in every 100 years. So I don't want you in this setup to turn to dust by having to wait, say, 100 years. So what I did is I shrank a day to 10 seconds. So what you see here is that every 10 seconds, a ball falls through this setup, the Galton board or pinball machine. And in the top bit, there are 4 outcomes, and in the bottom bit, there are another 4 outcomes. So for example here, the ball fell through and it says 2 seconds. So that means that it will rain 2 seconds in the setup of the 10-second Wetropolis day. Now again it says 2 seconds, so that's 20% of the time. So it can either rain 1 second when the outcome is 1 second, 2 seconds, 4 seconds, or 9 seconds during a Wetropolis day. Obviously 9 seconds, 90% of the time, is the most severe case. Now if we look at the bottom bit, this determines the location where it rains. So let's see what the ball does. The ball now says it will rain in moor and reservoir in the setup. So there are 2 places where it rains. But it can also rain only in the reservoir, only in the moor. Let's see what it does. Again, moor and reservoir, or the 4th one, no rain, and then it doesn't rain for 10 seconds. So I'm now looking at the Galton board, and the outcome is 4 seconds of rain in the moor. So I counted 1, 2, 3, 4. There was 4 seconds of rain in the moor. Now it says 1 second of rain in both moor and reservoir. So 1 second gone in a second. Now it says 4 seconds in the moor, and we get again 4 seconds of rain in the moor. And now we just have to wait till we hit the jackpot. So we'll just wait till we hit the jackpot. This is the extreme event. You need to get annoyed that it takes a while. So now there is 9 seconds of rain on the board in the reservoir. So it rains 9 seconds, and the city is not yet flooding, but very close to flooding. So now it's very wet. There is some minor flooding, 4 seconds of rain in moor and reservoir. So the moor has this extra feature that it's porous, so when the rain comes in, you see the water table rise, and then when it stops raining, it sinks again. And that relates to the slow release of the water into the river at the end. A return period is the a return period of an extreme event is the frequency with which, so the time period with which an event returns of that nature over time. So when you have an event with a 100-year return period, then on average it happens every 100 years. In Wetropolis, the return period is 6 minutes and 6 seconds, so on average the extreme flood event happens every 6 minutes and 6 seconds. But it might be irregular. There might be even 2 consecutive Wetropolis days with a super flood, and then not one for another 10 minutes. And the Galton board determines what happens. So a super flood with 2 consecutive extreme events, so 9 seconds of rain in Moa Reservoir, that happens in Wetropolis on average every 3 hours and 43 minutes. We have presented Wetropolis to flood victims in the Armley Museum in Leeds. We have presented Wetropolis at a workshop for flood victims and those people are very interested. And they want to understand what the frequency of flooding means.
Members of the public have been really excited by this exhibit here today. They've been very intrigued to see what's going on because we've got sort of the water flowing through. You can see things happening, so you can see the water slowly being released. So everyone's been really excited to see the flood of Smurftown at the very bottom. We've been able to show people how we're not just going to get a flood we can't get a flood every 6 minutes, or when we talk about floods in the UK, we get them every 1 in 10 year or 1 in 100 year events. So this just showed that you could be waiting here for 10-20 minutes for instance to see a flood, or you can be lucky enough to see 2 days where it floods back to back. And you get a really rare event, and you get a lot of waterfall, a lot of very intense flooding in the city.
Flood professionals get inspired by Wetropolis because it takes them outside their normal zone, and they start getting ideas and talking about flood control and flooding in a very enthusiastic way. So in meetings, it's useful to trigger the thinking of the flood professionals.